Now we'll discuss damped simple harmonic motion SHM. Okay, kindly watch the video.
Damped simple harmonic motion. Sometimes the motion of a simple pendulum swinging in the air slows down and down. This is because the air drags and the friction at the support opposes the motion of the pendulum and dissipates its energy gradually. These are called damped oscillations.
Please note it my definition of damped simple harmonic motion. It is automatically slow down.
In damped oscillation, the energy of the system is dissipated continuously, but for small damping, the oscillations remain approximately periodic. The dissipating forces are generally the frictional forces. The damping force depends on the nature of the surrounding medium. If
Please note it more. What are the factors damped force is depends. It is based on nature of the surrounding medium.
the block is immersed in a liquid, the magnitude of damping will be much greater and the dissipation of energy will be much faster. The damping force is generally proportional to velocity of the bob and acts opposite to the direction of velocity.
The last point also, the damping force is generally proportional to the velocity of the pop, the acts opposite direction of the velocity. One more question related to damping force.
If the damping force is denoted by Fd, we have Fd is equal to minus Bv.
Hi, this is a short video where I'll talk about damped harmonic oscillation. So here's a wave in the image, and on the left hand side is the starting point of the wave, which shows a very high amplitude, and by the time it comes to the right of the image, the amplitude has got killed off and it's almost zero. That's the whole purpose of damped oscillation. It's good for automotive suspensions where the car may have a high amplitude when going over a speed breaker or a pothole, and we want to reduce it to zero. The whole thing boils down to drawing a waveform for the oscillation. So draw a graph, and on the left.
See the amplitude ma. For starting it is maximum, but after it is slightly reducing again amplitude amplitude goes to 0.
Side you have the amplitude on the vertical y-axis, and the horizontal draw out the time on the x-axis. The yellow line, which is symmetrical for the waveform, also determines what's called the mean position. So let's say a car is at rest and it's not moving at all, then the chassis, the body, the wheel, tire, the springs, and the shock absorbers inside the springs are all at rest and in their mean position. So as the car goes over a speed breaker, you can see my previous video on that, or in a pothole, the mean position is disturbed. So when we talk about a suspension, it's just that the tire and wheels are hung by springs and shock absorbers from the chassis. Here in this simplified sketch, you can see a ring on the top, which is representative of the body and chassis, and the ball is representative of the wheel and tire. And the suspension system is represented by that spring there, although we should also have a damper in addition to that. This video is about damping of the oscillations. If you do not have a damper, the spring is likely to go on vibrating for a very long time. So if you have a suspension that does not have a damper, then those oscillations that we saw will continue for a very long time, which is not desirable for occupant comfort. So it's important to put a viscous damper, which is normally a hydraulic unit that's fitted inside that spring. Now coming to the amount of damping, that's a decision that's based on the assessment of comfort and the dynamics of the suspension. So here you can see a particular waveform where the oscillations are brought down to zero with, let's say, 4 or 5 bounces, and this is one choice. So this is called an underdamped oscillation. This particular image shows that the oscillations have been brought down pretty quickly in 3 iterations to x equal to 0. So what's appropriate, what's right for a particular application is a matter of judgment based on various test results, and it cannot be quantified in this particular video. But in general, we can say that an underdamped oscillation is good for passenger comfort. Thanks and have a great day.
This is next topic.
Let us discuss about forced oscillations and resonance. Natural frequency. If no external force acts on a system, then the system will execute oscillations of frequency nu naught, called natural frequency. Oscillations produced under the effect of an external periodic force of frequency other than the natural frequency of the oscillator are called forced oscillations.
Please notate what is force oscillation and resonance. The oscillation produced under the effect of an external periodic force of frequency. Applying external force.
Forced oscillations. If an external force Ft is applied to a damped oscillator, then Ft equals to F0 cos omega dt, equation 1, where F0 equals to amplitude of external force. Omega d means driven frequency. The motion of a particle under the combined action of a linear restoring force, damping force, and a time-dependent driving force, as represented by equation 1, is given by ma of t equals to minus kxt minus bvt plus f0 cos omega dt. md square x by dt square plus b dx by dt plus kx equals to f naught cos omega dt. Equation 2. The displacement
Please note the equation. Acceleration, this is velocity, displacement. It is equal to f naught cos omega t.
equation 2. The displacement after the natural oscillation dies out is given by xt equals to a cos of omega dt plus phi. Amplitude A is the function of the forced frequency omega d and the natural frequency omega. Analysis shows that it is given by A equals to f naught by m square minus omega d square plus omega d square b square power 1 by 2. Tan phi equals to minus nu naught by omega d x naught, where m stands for mass of the particle, v naught stands for velocity of the particle at t equals to 0, x naught equals to displacement of the particle at t equals to 0, omega equals to natural frequency.
Please note the formula.
Natural frequency. Case 1. Small damping, driving frequency far from natural frequency. Omega dB much less than m of omega square minus omega d square. A equals to f naught by m omega square minus omega d square from equation 3. From equation 3. Case 2. Driving frequency close to natural frequency. Omega d is very close to omega m of omega square minus omega d square much less than omega dB. A equals to f naught by omega dB from equation 3. Resonance. The increase in the amplitude when the driving force is close to the natural frequency of the oscillation is called resonance. Resonance is when the natural frequency of a system is equal to the frequency of an external force. This results in oscillating and an increase in amplitude. Resonance. The increase in the amplitude driving force is close to the natural frequency oscillation is called resonance. Resonance is when the natural frequency of a system is equal to the frequency of an external force. This results in oscillating and an increase in amplitude. Take two hollow boxed A and B. Open it one side. Place two boxes with their open sides facing each other with some distance apart. Mount two tuning forks of same natural frequencies, one each on the two boxes. Vibrate the tuning fork on the box A. The tuning fork on box B also begins to vibrate due to resonance. When A is vibrated, the air inside the box A vibrates, and these vibrations are transferred into the box B, and in turn vibrates the tuning fork on B. Activity on forced oscillations and resonance. Vibrate a tuning fork and place it on a table or bench. Then we can hear a loud sound, which is because the tabletop is forced to vibrate under the influence of the vibrating tuning fork. Suspend four pendulums A, B, C, D, in which A and C are of same lengths, B and D are of different lengths. When pendulum A is oscillated, the other three pendulums also start oscillating. A and C are in resonance with each other, and the oscillations of B and D are called forced oscillations. Examples. When soldiers are crossing a suspension bridge, they are asked to break their steps. This is because when the frequency of the marching coincides with the natural frequency of the bridge vibrates with larger amplitude and collapses due to resonance. A radio is tuned to obtain a clear sound, such that the frequency of the radio have to coincide with the frequency of the incoming electromagnetic waves. We can find the velocity of sound using resonance phenomenon with resonating air column experiment.
Okay, now we'll discuss related question papers now. One minute, it is loading. Already you know very well. This is our revised syllabus. This is the mark weightage for each chapter. First to five chapter combined together, you will get 23 marks. Next up to gravitation, work energy power, system of particle, rotational motion, 17 marks. The properties of bulk matter, thermodynamics, kinetic theory of gas, combined together 20 marks. Oscillation, waves, combined together 10 marks. Total 70 marks for you. Theoretical exam. Remainder 30 marks, that is a practical exam. That purpose we are asking from you the activity and other things also. You can submit. That is the last day for Saturday. Based on the revised syllabus only, you will get the question paper. Physical world, just know the knowledge enough. Unit and measurement, kinetic, laws of motion, work energy power, gravitation, thermodynamics, behaviors of gas, oscillation. So oscillation also completed. Afternoon class will discuss the book exercise question. This is only quantitative ideas only. Okay, related resonance, the force and the damped oscillation. So that idea also you will get. I know very well. Okay. Now we go for the question pattern. Overall 33 questions. There is five sections. Section A, B, C, D, and E. Section A, one more question. R question it is a fourth one R question. Then you can attend only one question. No need to attend two also. Just attend only one question. Then 1 marks. Again question number 11, 12, 13, 14. 4 question for assertion and reason type question. For example, both assertion and reason true, but reason is correct explanation of A. Then you can select option A. Both also wrong. Assertion and reason both also it is wrong. So A is false, R also false. You can write only answer D. So that is the assertion and reason type question. In this related question also we conducted one exam, weekly test. You know very well. Next question number 15 and 16. It is the case study type question. Case study means they will give one paragraph. Based on the paragraph, they will ask MCQ questions. That MCQ pattern also we conducted, but I didn't give for you that passage. But we conducted MCQ questions. 5 questions it is there. You can select any four. Two questions. Question number 15 and 16. Next 2 more question. 9 2 marks. In 2 mark also R question it is there. Next 5 more question. Sorry, 3 more question. 5 3 more question. In 3 mark also R type it is there. Not for all the question. Two or three question only. Section E 5 mark. So all question R type. 31 also R. 32 also R. 33 also R. So this is the new sample paper for class 12 and as it is for class 11th also same pattern based on your revised syllabus. Okay. Any doubt? If you have, you can ask.